Okay, now we have done compound angles and double angle formulas. You know them on your formula sheet, you know how they work. But it can be asked like a theorem. Now you know the theorems, grade 11 theorems for the geometry. You had 9 theorems, but 4 of them were for theorem proofs, formal proofs. This is also a formal proof. But otherwise, other than geometry theorems, you know that of the 4 you were going to get one for sure in grade 11. Now you're going to learn another 2 in grade 12, and in the June exam, November exam, and prelims, you're always going to get 1 out of the 6. This, we don't know. If it gets asked, if it doesn't get asked. But if it does get asked, it'll be something like 3 or 4 marks. The way that the question is asked says that if we assume or we know that cos alpha minus beta, is it the plus one? Let me just check. Yes, minus beta is equal to, now you know this, please help me, is cos, right, and then the alpha beta, right, alpha beta, plus. So you proved that in your investigation, you already proved that. Happy on that? So since you know that, they say, use this to deduce the following. And the first one that they ask you to deduce is the plus one. Now you know that it's going to be cos, sin, but with a minus. But if you write that down now, you have no marks. Nothing. The deduction is a theorem. Now if you do that, this whole thing that's a theorem is going to be 4 marks. So if you just write down the answer, no marks. You've got to use this formula to deduce it. So in other words, in your formula, you have cos and alpha and minus and beta, and you know that that's the formula. So if you want to use that, we're going to take cos alpha plus beta, and we are going to do what? So we are going to use the knowledge that we have to apply it to the next work. So the knowledge that we have is that if there is a cos and 2 angles with a minus in between, then I've got to adjust this a little bit and say, let's make a cos of a minus in between. Now, how on earth am I going to get that right? We're going to say alpha stays alpha, and then what do we do here to still get to plus beta? Still remember that? Okay, but you're forcing it to where I want it to be. So once I do have the minus there, then the formula says, we're going to say cos, sin, cos, sin. And the 2 angles as they are is alpha minus beta. Alpha minus beta. And if it makes you feel better, you can even put both of them in little brackets. And the knowledge that you're using has a plus in between. It's not because of the formula that you already know, it's a deduction from there. Then you've got to show me that you know that this is a negative angle that's becoming a positive. The ratio then has to become negative, but not cos. So that's why that just stays cos alpha, cos beta. Over here, it's going to become negative sin beta. Negative angle becomes a positive angle, but the ratio becomes a negative, except for cos, but it's not cos. And then I'm actually done. I could have actually done that in one step, because the only thing that happens now is that a minus times a plus is a minus, and you still then have sin alpha, sin beta, and cos alpha, cos beta. Now, for the first 5, 6, 7 times that you write this out, it's going to mix sense. Just take a little bit of time, mix you up a little bit. But after knowing what to do here, it's going to take you 5 minutes just to go through that again. So the question in exam will be, if you know that this, or use this fact to deduce a formula for this next one. Now, this is not the only one, except for cos alpha plus beta, then it is sin alpha plus beta and sin alpha minus beta. So any which one of them can be asked for a 3-mark or a 4-mark question. So then the marks would be for taking it to be minus, applying it to that one, using the negativity and getting into the answer. So that's the first one. If the question then says, knowing this fact, use this fact or use this identity to prove the following identity, or deduce a formula for, they don't tell you what it is. You know it's going to be sin cos sin, and the plus is going to stay a plus. You know that. Will that be worth a mark? Nope, because we know that and it's on your formula sheet. But you've got to use this. So in other words, highlight that for yourself and tell you that that is what you've got to force in here. So I have to have cos here. How on earth will I get it to be cos? Co-function, which means you've got to do 90 minus what? That exact angle there. Now, I'd rather want to put too many steps in so that you can understand. That now means that you've got 90 minus alpha minus beta. Do you agree?
Yes.
But then, according to me, there's 3 angles there now. And this formula goes according to 2 angles. 2 angles. But then all you do is you put those 2 together, because we're aiming for cofunctions. So we're manipulating and forcing it to be cos of 2 angles that are subtracted. If I have cos of 2 angles subtracted, the rule says it's then going to become cos, sin, according to that. And according to that, there's a plus. And the 2 angles are alpha and beta. What are these 2 angles? Alpha is now 90 minus alpha. And then the beta there is after the minus. So it's just again beta. So that you understand what you're doing. You're using that to prove the next one. So now in the next step, I have to say cofunction. So it's poof, puff. Poof, alpha, puff, sin. Right? Nothing to do there. And then this one again is going to be cos, poof, puff, sin. And we're done. So it's going to be marks for knowing that you've got to go to cofunctions, knowing that you've got to split them up and use that formula. Nothing for the final mark. Nothing. You've got to get there by using this technique. If it gets asked, 3 marks, maybe 4 marks. Writing error, this shouldn't be sin. I rewrote it, but I rewrote it wrong. Sorry. To prove the last one, you have to use this original green bar thing. You've got to make this a cos. How do we change that into a cos? 90 minus. 90 minus what? That whole thing. Meaning that I've actually got 90 minus alpha plus beta again. But now remember, don't lose focus. It is true that it's 90 minus alpha. Minus times a minus is a plus. But I am going to leave it like that because I'm forcing it to look like that. I want that minus there, according to this reasoning that I'm using. So this cos, I'm still happy on that everything is fine. But now I'm using that formula that says if it's cos of 2 angles, do you see the 2 angles? If you don't, now you see it. 2 angles that are subtracted. Then we use the formula that says cos, sin, and it has to be plus, and it has to be the 2 angles. The 2 angles that are 90 minus alpha and minus beta. Because we didn't want the plus there, we wanted the minus, and then the other angle is negative beta. So again here, negative beta and 90 minus alpha. So it's a trickery here, forcing it to look like the one that I would like to use. This again is going to give me a cofunction. It's going to be sin alpha. Negative angle becoming a positive angle, ratio becoming a plus, or a negative, but not cos, except for cos. Negative angle becomes positive, and the ratio becomes negative except for cos. Same thing here, so it's going to be plus cos alpha, co-function, poof, puff, poof, gone is the 90 minus, puff, sin becomes a cos. But then this one will be negative angle becomes a positive angle, but the ratio becomes a negative. Now you could have already put the minus there in the front. I'm sure they wouldn't have deducted marks for that. But you know we want to see you use the reduction formulas, knowing what the negative angle does to the ratio when it becomes positive. And then the final answer is just going to be a minus times a plus again, giving me a minus. So that it's sin, cos, sin. So the only thing that happens there is a plus times a minus is a minus. And then if you've done this without even thinking about the rules, now we're checking it out again. Sin alpha minus beta is sin cos sin with a minus in between, and it worked out fine. 3 marks, maybe 4 marks. If it gets asked, theory. It's like the geometry theorems that you've got to know out of your head. Yeah. Basically, you have done all your trig. You just need to have a lot of exercising. So when you start off grade 11 and grade 12 with your trig, this usually is the first question. What am I asking? If something is given, write in terms of t.
Butterfly.
It's the butterfly sum. If you don't know that, you haven't studied enough yet to know that. Usually the first question is one that uses Pythagoras and cos and the butterfly. So if we have sin 56 equal to t, write in terms of t, you know it's the butterfly sum. It will say it's the butterfly. It says, hey, I'm the butterfly sum. If you have done enough of it. Which quadrant is my butterfly? How come? Duh, 56 degrees. Are you with me? And then the t, it's usually in terms of k. We like k, right? But then t, no problem. But then I need to use cost. Okay, cost is definitely first quadrant now. And then I've also got to use Pythagoras. Where's the sides? It's t over
1.
Nice, you see it's repetition.
Yes.
Sometimes they can give you something like t over t squared or t over root t, or I don't know what they could do there, and then you just use those two sides. So sin being opposite over hypotenuse, meaning that that's my 1, I can then get my third side by using Pythagoras. So the only two things that can happen is either I'm not looking for the hypotenuse side, then it's a minus sum, or I'm looking for the hypotenuse side and it's a plus sum. So in this case, it's going to be a minus sum, in which I'm going to say 1 square, which is 1 minus t squared, and that's inside of a square. Remember last year in grade 11, you took a while to get into it there. But if I want to work it out with Pythagoras, I have to say Pythagoras. Please don't forget to give Pythagoras his due, so that I can go on to answer the questions. Now in the questions, we are going to write, what am I testing?
No, you're testing
Negative angles and bigger than 90, so reduction formula. So we're testing all these sorts of things, especially the new things that we still got to test. So first of all here we would say, but negative angle becomes a
negative
positive angle,
with the
and the
negative
ratio becomes negative
but
if it's not cos, but it isn't cos. Then we've got to take that angle and reduce it to an acute angle by saying, what are 3 choices? 180 minus, 180 plus, 360 minus. This is like breathing in trig. This is the basic of the basic. So 236, is that a 180 minus or a 180 plus or a 360 minus?
360 minus.
180 plus. And if you make a mistake and try a 360 minus, you would have found that it's 100 and something, and that's not acute. So I'm trying the wrong one. So it's 180 plus what? 56, do you agree? Now remember, we taught you, you can always write 180 plus 56 still there, and it goes poof. Poof, that's gone to get here, but you have to remember to check your quadrant. Then it's going to be third quadrant where sin is negative. What about that negative? It stays there, but the reduction is still a negative, meaning that this is going to become a positive. And 56, now, if I go for sin 56, that will mean I have done this for nothing. But it's going to help me later on. Because sin 56 was actually given right from the start. Please don't forget to answer the question. Question was,
Right.
find in terms of t. So this is not done. In terms of t, that would then just be t, which is a silly mark to lose if you didn't write that. Okay, so obviously I was still wanting to use this somewhere. So what about test 34? Are they crazy? 34?
Really?
You have to?
Make a call. Oh.
Please don't forget co-functions. That's not grade 12 work. That's grade 11 still. Because those two add up to 90. So I can easily change 34 into 56. Or if I know that this is 34, you can do it in one of two ways. Either you can go and stand there by 34, here I am, see me, and sin is opposite over hypotenuse, so I'm definitely using this Pythagoras. So if it's opposite over hypotenuse, that will just mean the root over 1. Ma'am, do I need to write it over 1? Okay. Could I not have said, but it's the same as cos 56? Go to 56 and say cos is adjacent over hypotenuse. Well, it's exactly the same. You're not going to get more marks or less marks for the one or the alternative. So is that anything new from grade 11?
No.
But then? Double angle, 34, or what else can you use? Maybe even? Compound angle, what? How about 34 plus 34? As long as, and this is the crucial part, you've got to get to something with 34 or 50, 6 or both, it doesn't matter, but you've got to have 56 or 34 there. I can't ask you something like cos 69, because how am I ever going to get to something that's got something with a 34 and a 56 in there? So I can't just take stuff out of thin air. It's got to be something that's going to work for me. Okay, so I'm saying we can either use the compound angle, 34 plus 34, which will then mean cos, sin, which we've done. Or we can use a double angle. We haven't seen that in a minute or two. So if it's double angle, then how many cos double angle formulas do I have?
Like 3.
3. Okay? And which one would I like to use? Because now I'm going to use 34, right? So it really doesn't matter. If I was sure it's going to be 56, I would like it to go for sin 56 because it's there already. I don't even have to read anything off. So sometimes you're going to make better choices, not so good choices, but any choice here, remember your middle name is alternative. So anything will work here. Sometimes you're going to have a little bit more to do in between, and I have a little bit less, but we're still going to get to the same answer. So let's say that that was cos of double 34. What would that then be? Either cos 2 cos 34 minus 1 squared, and or 1 minus 2 sin squared, and it doesn't matter. You could even go for cos squared minus sin squared, but then I've got to read two things off of my graph, making it more difficult or more work. So let's just take any one, 1 minus 2 sin square of 30. Or where does that come from? It's a formula. Double angle formula. And then I've just got to read off 1 minus 2 times the sin 34. I've got to read off there. Now sin 34 is, you've just done it, is that root 1 minus t square over 1 if you want. If you don't want, it's fine. And then you'll have one more mark just to simplify that. Because a square and a square root are going to cancel each other out. You're going to have 1 minus 2, and inside the bracket it's going to just be 1 minus t squared. Square and the square root cancelled out. I'm still not quite done. 1 minus 2 plus 2t squared when I time in the negative 2. And still not quite done. 2t squared minus 1, and it doesn't matter the order that you write that there. Minus 1 plus 2t squared, doesn't matter. Okay, a last one. Sin 94. Man just said to you, I cannot just thumbs up and ask you anything. 94 doesn't look to me like it's working. Ideas? 60. Because you can use 34 44, 56, and please don't forget about the special angles. Because it's true that you could say 50 plus 44, and then you have to get to 34 and 56. But if you used 60 and 34, that could help me a lot. Are you with me? Because now that's going to become sin cos plus cos sin, and it's going to be a horrible answer, but in actual fact I'm just aiming to see if you get this. Write it out. Then you've substituted back in, and then the substitution would most probably make it a horrible simplification, but that's the last mark of it. Sin 60 and cos 34 was 34 is t. Cos 60 and sin 34. Are you happy on that? We've just substituted it in. There's not much to do here than put it all together and write it all on top of, because you can put that all on top of one, all on top of each other.
No.
So you can put them all on top of 2 and have root 3t at the top there, and we've got just that root 1 minus t squared also on 2. And really, guys, that's not what my sum was about. It was, did you get a connection with your sketch to get to 34 or 56? And did you substitute? The answer itself, if you got here, I would say 4 marks. So that's what it was all about, to get into this answer. Not to how to get LCD and what else. Okay.